So suppose all you need is the direction of a vector, right? You don't really care how long it is. You just want the direction because, for whatever reason. So then I don't need to have like a full-blown, 1,000 unit vector. All I need is something that points in that direction. So all I need is, a little bit like a 1 unit vector that just gives me the direction. That vector is called a unit vector. All right. What a unit vector is a vector that has a magnitude of 1, right? But it's got a direction. It must have a direction, right? That's the whole point of it. Okay, so normally, if you have a vector v, normally the unit vector is given the symbol u, and it will have the same direction of v, but a magnitude of 1. All right, so, okay, let me do this. You always must put a vector symbol. In the book, it's bold, but you have to put a vector symbol, okay? Okay. All right, so take a look at this. This is vector v. That whole thing, starting from the beginning to here, that blue vector is vector v. All right? Vector v has a length of 2.5. All right? And now what I need is vector u. So to make it a unit vector, so then what do you do to the length in order for the length to be 1? Divide by itself, right? So if you have any number, this has a length of 2.5. What should I do to it in order for it to equal 1? What do you do to a number in order for it to equal 1? You divide it by itself, right? So this vector v, if I divide it by its magnitude, gives me the unit vector u. Okay? So, more formally, u is the vector v divided by the magnitude of vector v. Okay? And there it is right there. Okay, so suppose we have vector v as 4, -2, and I want to find a unit vector u. All right, so what I need to do, first, I need to find the magnitude of v. So find magnitude of v. All right, and how do we find magnitude of v? It's the square root of both of the components. And look, I'm going to square the 4. And then, yeah, that's a -2, but when I square it, it'll be a +2, so I don't bother with the negative, right? You will learn later on, to, just be quick about those and not bother with them, okay? So v is the square root of 16 plus 4. It's root 20, okay? And that, of course, is 2 root 5. Is that clear? Okay. Now, u is going to be vector v divided by the magnitude of vector v. I'm sorry, this is magnitude. All right? So u is going to be, what's vector v? 4, -2 divided by 2 root 5. Okay, dividing is the same as multiplying by a reciprocal, right? And so this is the same as multiplying by a scalar. So what you do is you divide each of the components by 2 root 5. So this is going to be 4 over 2 root 5, -2 over 2 root 5. And of course, you have to simplify. You don't necessarily have to rationalize, but you have to simplify. So this is 2 over 2 root 5, comma, -1 over 2 root 5. 2 over root 5, sorry. So now look. Obviously, show me this, okay? You don't have to show me that next step and then, show me this. The middle step, I just did it to show you guys what we're doing, okay? All right. Questions? Yes. Okay. Questions? Okay. So a unit vector has to point in the direction of the original vector. So it could point in any direction, right? Now, there are special vectors. So you're probably beginning to guess by now that yes, a vector can point in any direction, but the ones that are purely vertical and purely horizontal, those are the special vectors, right? That's like first-class vectors. They're so first-class that the unit vectors that are purely vertical or horizontal are like a whole VIP group of their own. All right? Question.
Okay, this could sound like so like, for example,
talking about those VIP vectors, these are unit vectors that are strictly horizontal or vertical. All right? So a unit vector in the same direction as the x-axis and the y-axis, that's how you say it. A unit vector in the in the direction of the x-axis or the y-axis is denoted by I and J. Okay, I and J are like famous. Okay, so I don't know, like what, like okay, name a sport, name like the most famous players in the sport of the time. Those are your I and J. Okay, except famous players in a specific sport come and go, right? In the 70s, it may have been something else. In the 90s, it may have been somebody else. Now it's somebody else. I and J, famous MVPs throughout time of the vector sport, okay? So I and J, in the textbook, it's going to be bold again because it's a vector. When you write it, it's, first of all, like an italicized I and an italicized J, but to denote that it's VI and the VJ, they get a little hat. Okay? It's called a chapeau. It's a French word. It's a little hat. So it's I hat, J hat. In the cool, math and physics world, it's called I hat, J hat. Okay? And then there is a K hat as well in the Z direction. Okay? So it's hat. Chapeau. It's like chapeau. I know. Yeah, it's fancy. But we don't call it I chapeau. We call it I hat, J hat. Now, we don't want people to laugh at us now. Okay, so.
I'm just going to walk around saying chapeau.
I know you will, Zachary.
Bang, bang, shots fired.
Okay, so notice now. Here's why we like I hat and J hat. This is an I hat and a J hat. Okay, they go, one unit to the right, one unit up. Okay, so notice now, I can create any vector by just putting together little building blocks of I hats and J hats. So for instance, I could put together, it's like little Legos. I could put together 3 I hats, and I could put together 1, 2, 3, 4 J hats, and that creates for me that vector V. Okay? Yeah, you have to do a hat. So now, how did I create that vector hat? That vector in the green. I had 3 I hats plus 4 J hats. Yeah. So now look. Now. Correct. Oh, wait, the dot, you mean like the I dot? Okay, so that's just style. I know you're supposed to dot your eyes. It's so time consuming for me. I don't dot my eyes. It's wrong. But really, listen, that's just preference. Just put the hat. Yeah. Okay. So now, this vector V now, I can write vector V in 2 ways now. One is in component form, 3, 4. Is that right?
Yeah.
And one as a linear combination of I and j, 3i plus 4j. So, two ways to represent vector v. Okay? So now, the purpose of this quiz tomorrow is to find out, do you know your terminology? If I tell you to write v in vector form, in vector component form, do you write it that way? If I tell you to write v as a linear combination of I and j, can you then go there? Do you know that they're the same, but different ways of writing them? Okay? So, take a look at this. Let DE be the vector with initial point here and terminal point here. Write DE as a linear combination of vectors I and j. Okay? So,
What's it called? Linear combination of I and J?
yes. So now look. DE, what is DE? Let's just write it in component form first. It's easier to organize. So it's going to be 2 minus negative 3 and 6 minus negative 3. So DE in component form is 5, 9. Hang on. DE as a linear combination of vectors I and j is 5i plus 9j. Okay, so that's that. Okay, let me go on and then I'll take you. Okay. All right. If the magnitude, all right, so let's go into some real stuff. If the magnitude, if the magnitude and the angle a vector makes with the x-axis is known. So if you know the magnitude of a vector v and the angle, right, then you can decompose it into horizontal and vertical components. We've already done this. So if I have vector v, and if I know this, and if I know the angle, right, then you remember we said last time x is the vector times cosine theta. Remember we said that last time? And y is the vector times sine theta, right? The magnitude. Huh? Fabulous. So now I can write these two ways. Remember last time, so I could write the vector like this in component form, v cosine theta, v sine theta, or I can write it as v cosine theta I plus blah, 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 j. Okay? So, let's talk about this for a minute. Let's do this for a minute. My eyes are watering. I'm getting emotional from the vectors. Okay. Okay. So, it says to write the component form. All right? So look. The x component is the magnitude times the sine or the cosine? What? Which one? Cosine of 60. The y component is 7 sine 60. Now look, before you ask any questions, hang on. Let's write this in component form. Vector v will equal 7 cosine theta, 60, comma 7 sine 60. Okay? Now, I know that 60 and 30 and, those angles are ones that we could just simplify, so you must simplify them. So suppose this was 50, right? 50 degrees, and you don't have your calculator. It's perfectly acceptable to leave it in this form. Not if it's 60, but like any other angle that, that's not a special angle.
If you have
Okay.
a calculator,
Huh?
if you have a calculator, then you have to figure it out.
Right. Okay, so now we simplify this though. How much is sine of 60? Let's start with the sine. How much is sine of 60? Root 3 over 2, so the cosine is 1/2, right? So this is 7 times a half, 7 times root 3 over 2. So it's totally fine to leave this as this. Okay. Okay, we're here now. So this is component form. Now, if I wanted to write as a linear combination of I and j, here's what I would do. I would say V is equal to 7 cosine 60I plus 7 sine 60j. No brackets. All right?
But this one says component form.
I know, and we're going above and beyond.
The
Okay?
component form always has.
Yeah. Or this will be 7 over 2I plus 7 root 3 over 2j. So, to sum up, if you're asked to provide this in component form, this is component form. If you're asked to provide this as a linear combination of I and j, this is it. Okay? Okay. Now, how do you find the direction angle of vector P? Let's draw vector P. All right, vector P goes 2 in the x direction and 9 in the y direction. Here. So what does vector P look like? That. Now, to find the direction angle, this actually requires not a lot of pre-calc. It's just algebra and geometry. I can write this as a right triangle, right? And this is a length of 2, and that's a length of 9. And if I want the angle here, how would I find it?
The angle there equals 9 over 2.
Tangent, good. So tangent of theta is equal to 9 over 2. Right. So what you're going to remember is this. This is the x and this is the y. Do you have to draw the diagram? Not really. Okay. And we want this in degrees. So theta is 77.5 degrees. Does that make sense? Does it make sense that it's got a high? Yeah, it does, right? It's going to be close to. Huh? Because look at what you have. You're given the horizontal and the vertical, and you want to find that angle. So it's opposite over adjacent. Right, but it's you're always gonna be given the x and the y component. So you're always gonna be finding the tangent. Okay. A quarterback running forward at 5 meters per second throws a football with a velocity of 25 meters per second at an angle of 40. So he was running 5 meters per second, and then he threw it with a velocity of 25 meters per second. So if you're already running at a certain speed and then you also throw the football, your two velocities will add somehow, okay? And now these are both vectors, so they add in as components, not straight addition. So the ball won't have a speed of 30 because they're not in the same direction, okay? All right, what is the resultant speed and the direction of the pass? Okay, so I need to do a vector addition diagram because this is a picture. This is not a diagram. So I need to do a diagram. All right, So he was going 5 meters per second. I will call that, I don't know, the quarterback, Q. All right. Then he threw the ball with at a velocity of 25 meters per second with an angle of 40 at the horizontal. So look, if that's the horizontal, that's what it looks like. All right, and that's a much longer one, right? So we'll call that B for ball, and that's 25 meters per second. So what's the resultant? That's the resultant, and that's Q plus B. Hang on. Okay, so now I need to know the resultant speed and the direction. So in order for me to be able to add these, I need to write as component form. So what's Q as component form? 5 and 0. What's B in component form?
0 to 25.
No.
Oh, it would be 25
25 cosine 40, 25 sine 40. Okay? Unless it's purely horizontal or vertical, you've got to write it in component form. All right? If it's got an angle that's not horizontal or vertical, you have to write it as V cosine theta, V sine theta. Now, R, we add these. Okay, you add this one, 5 plus 25 cosine 40, and then 0 plus 25 sine 40. Okay, all right, time's up. So I think I'm going to pick up from here.